this lesson, you will learn to use data from a sample survey and a simulation to estimate a population mean or proportion and develop a margin of error through the use of simulation models for random sampling. Consider the following situation. If you were to toss a paper cup up in the air and then let it land on the ground, what proportion of time will it land upside down? Find a cup and then toss it in the air and let it fall 100 times, then record the result. Make a prediction for the proportion of times it will land upside down. Go ahead and pause the video and try it yourself. I conducted the paper cup throw with my particular cup. I tossed it 100 times and these were my results. My cup landed upside down 12 times out of 100. It landed sideways 85 times and upright only 3. The number of times it landed upside down is a proportion of 12 over 100, or 0.12. Based on my results, what range of proportions are reasonable for estimating the true proportion of times a cup lands upside down? We can't always repeat an experiment like this over and over to find which proportions are reasonable. So we have some formulas that will help us. In AP Statistics or in College Statistics, you will go into detail about confidence intervals and margin of error. For our purpose, I want you to know what a margin of error tells us, as well as how to find a 95% confidence interval. The range of possible values, the confidence interval, is the amount of the margin of error above or below the statistic. This can be represented by the formula, the statistic plus or minus the margin of error. So we have the statistic plus or minus the margin of error for the amount above or below. The margin of error is calculated using the sample size and the confidence level. A higher confidence level margin means a wider margin of error, since the higher confidence level will include more data points. For this class, we are going to look at the 95% confidence level, which gives the constant value here of 1.96. So the formula for the confidence interval with a 95% confidence level is the statistic, represented by p with a little hat, we'll call it p hat, plus or minus 1.96 times the square root of the statistic, p hat, times 1 minus the statistic, and then divided by the sample size, n. In the cup example, the statistic, or p hat, is 12 out of 100, or 0.12. So we'll let p hat equals 0.12. The sample size, n, is 100, since I tossed the cup 100 times. Plugging these values into the formula for the margin of error, we get 1.96 times the square root of 0.12 times 1 minus 0.12 divided by 100. So you may use a calculator to solve this by all means. When you do, you will find that it simplifies to 0.064. 0.064. This is our margin of error. The confidence interval can be found by adding this amount to the statistic and by subtracting it from the statistic to find the high and the low end of the interval. So for the interval, we have 0.12 plus 0.064, which is 0.184. And we have 0.12 minus 0.064, which is going to be 0.056. This means that for this example, the confidence interval, the interval of possible proportions that could represent the true proportion, is from 0.056 up to 0.184. Now it's your turn. Determine the margin of error for the proportion of times the cup lands sideways, as well as the confidence interval of possible proportions that could represent the true proportion for a 95% confidence level. Pause the video to work out the problem. Click play to continue. Let's look at how we would solve this problem. Recall that the formula for a confidence interval at a 95% confidence level is the statistic plus or minus the margin of error, where the margin of error is 1.96 times the square root of the statistic times 1 minus the statistic divided by the sample size n. In this case, our proportion, or the statistic, p hat, is 0.85. So this would be equal to 0.85 plus or minus 1.96 times the square root of 0.85 times 1 minus 0.85 divided by the sample size, which is 100. So, using a calculator, you will find that all of this simplifies down to the margin of error right here will be 0.07. So, the confidence interval is the statistic plus or minus the margin of error. So, for the confidence interval, we'll have 0.85 plus 0.07, and we'll have 0.85 minus 0.07. 0.85 plus 0.07 is equal to 0.92. So that will be the high end of our confidence interval. And 0.85 minus 0.07 is equal to 0.78, which will be the low end of our confidence interval. Putting this together makes our confidence interval the interval from 0.78 to 0.92. What if I wanted to estimate the confidence interval for a mean instead of a proportion? I asked 50 students the number of hours of sleep they got on Sunday night. The mean of my sample is 7.5, and the standard deviation is 1.8. What would be the margin of error and confidence interval for a 95% confidence level? The formula for a confidence interval with a 95% confidence level and a sample size of 50 is the mean plus or minus the margin of error. For a mean with a sample size of 50 and a confidence level of 95%, the margin of error can be calculated as 2.009 times s, the standard deviation, divided by the square root of n, which is the sample size. The 2.009 is the constant specific to a 95% confidence interval and a sample size of 50. To solve this, we just substitute our mean, sample size, and standard deviation into the formula. We get that the margin of error is going to be 2.009 times the standard deviation, which is 1.8, divided by the square root of the sample size, which is the square root of 50. Okay? So the margin of error, when you plug this into your calculator, you get 0.51 for the margin of error. To find the confidence interval, we add this amount to the mean to get the high end of the interval and subtract it from the mean to get the low end of the interval. So we have 7.5 is the mean plus 0.51 and 7.5 minus 0.51. When we add 7.5 plus 0.51, we get 8.01. And when we subtract, we get 6.99. This means that the number of hours slept is most likely between 6.99 and 8.01 hours. We could say that we are 95% confident that the true mean number of hours slept is between 6.99 and 8.01. Take a moment to make sure you have the purpose and procedure for finding a margin of error in your notes. The purpose is to determine a range of values to estimate a parameter. The procedure is to run the activity to collect data and use the formulas to determine your margin of error and eventually the 95% confidence interval. The formula for proportions is the statistic plus or minus 1.96 times the square root of the statistic times 1 minus the statistic divided by the sample size. The formula for means with a sample size of 50 is the mean plus or minus 2.009 times s, the standard deviation, divided by the square root of n, the sample size. In this lesson, you learned to use data from a sample survey and a simulation to estimate a population, mean, or proportion, and develop a margin of error through the use of simulation models for random sampling. See you next time!